All right, so let's take a look at 9.1, question 7. I really like this question, and um, here's what's going on. Professors collect data on eye color. They're interested in looking to see if the proportion of male students that have blue eyes is different from the proportion of female students that have blue eyes. They're using a zero point zero 0.05 significance level to test that claim that they are in fact different. Um, and we're going to say that, the first sample is the males and the second sample is the females so that we can, take care of bookkeeping. Now, one of the things that's so important about statistics is using critical thinking skills. In other words, when you read a problem like this, you want to get a general idea like, hey, what do I expect, right? Do I think that men and women are going to have different, um, proportions of eye colors? So, in my opinion, I feel like in this problem, we're not going to see a significant difference between a proportion of men with eye color with blue eyes and a proportion of women with blue eyes. But, that's why we go to the data, right? So the claim is that, first of all, the null hypothesis is always a statement of equivalence, right? And in this case, the alternate hypothesis is that they are not equivalent. So we're going to select that. Now, we're asked to identify the test statistic and the p-value. So what I'm going to do, one more thing too. I just want to show you how I set up the problem, right? So I just wrote down it's problem 7. It's eye color data. I labeled what the populations were, and then I wrote down the number of outcomes favorable and the total number of outcomes for each of those two populations. And then I wrote down the null and the alternative hypothesis. And then I just wrote down the fact that, hey, this is two-tailed, so we don't have to adjust for confidence interval. I'll explain that in a minute. All right, so there's all the information we're going to enter in StatCrunch. I just wrote it down. So I'm going to go ahead and open StatCrunch. I'm going to show you something else too, right? So this is from a previous problem. It's already populated, but it's the same type of problem. I can actually go into options and then edit, right? And if I edit, I don't have to go back out of StatCrunch and redo everything. But I'm going to do that just for, illustrative purposes. So I go to stat, I go to proportion stats, I go to to sample, I go to width summary because we're not using raw data. And then those numbers I wrote down, I'm just going to enter them. So I got 345 out of 933 for the men. And then I've got 402 out of 1110 for the women. And then now I just want to take a look at my hypothesis test and make sure that this is accurate. So the difference is equal to 0, and then the difference is not equal to 0. Okay, so that's accurate. And what was our alpha level? Let's take a look, see what our alpha level was. We had a 0.05 alpha level. So let me write alpha is equal to 0.05. All right, now this is not necessary because we're just going to compare, but I like to show the critical value, and I like to put the significance level in here. So let's go ahead and click compute. All right, so here's our results. We have a z-statistic of 0.36, rounded to 2 places, and we have a p-value of 0.72. So let's put this, in here, 0.36, and then 0.72. It says rounded to 3 decimal places, but there's only 2. So what's the conclusion? Well, I mean, it's not even close, right? The p-value is greater than the significance level by a lot. So we failed to reject the null. There is insufficient evidence to warrant rejecting the claim that the proportions. Wait, hold on a second. What's it say? There evidence to warrant rejecting the claim. That the proportions are the same. Okay, just double checking the wording. So we're going to construct an appropriate confidence interval. So I want to show you again how we can just use the edit feature. So we're just going to go to edit instead of going out and typing all this information back in. And we're just going to change this to a confidence interval and then hit compute. And I'm going to write down these values of my confidence interval of negative 0.034 and 0.0495. That's actually just going to become 0.050 or 0.05 when we round it up to 3 places. All right, so let me enter those values. I've got negative 0.034 and positive 0.05. All right. And now, what is the conclusion based on this confidence interval? Well, the conclusion is the confidence interval contains 0, right? So it appears that the two proportions they're equal. There is not sufficient evidence to support the claim that they're different. So what type of sampling is used here? Well, this is clearly convenience sampling, right? He's not going out and randomly selecting people outside of a shopping mall or something like that. He's just taking students and he's doing a convenience sample. Now, is it likely that this is biased? So convenience sample is historically a biased sample. However, again, this idea of using, critical thinking skills, would the proportion of students, statistics students, be different from the general population? I would suggest that the answer is no. So it is biased, right? The sample is randomly selected, but there's nothing indicating that the prevalence of blue eyes is different amongst statistics students than in the general population. Well, what happened? Oh, no, sorry. No, it is not biased. My fault. All right. I clicked yes. My apologies. All right. That concludes this lesson.